Hello everyone, and welcome back to the C-Cube channel. This is a Tier 1 video, so this is for those doing GCSE Maths Foundation tier, and those who wish to, start from the basics. So today we're going to be kind of bridging ourselves into the higher tier GCSE Maths for the Edexcel example, that is. So this is kind of where we're going to transition to the Tier 2 videos soon. So this is kind of the starting point for that. So this video we're going to be focusing on quadratic expressions. We're going to kind of giving ourselves an introduction to what quadratics are and what they mean in terms of the algebra. When I do the graphing stuff in another video, in another series, we will be looking at how to graph quadratics and learning about the maximum, minimum points and all that kind of thing. But for now, we're just looking purely at quadratic expressions themselves, the algebra part of it. So to begin with, we're going to quickly recap ourselves with expanding brackets. So we've said many times that when we have situations like this, we can multiply the number on the outside with the expression inside. So let's do it very quickly. So remember we did 2 times x, so we got 2x, and then plus 2 times 3. So 2 times 3 there is 6. Oh, that's a bad 6. There you go, that's a 6. So we just simply express this out as 2x plus 6. Easy as that. With the second situation, we've said, again, we take a variable on the outside and multiply it by the expression inside. So x times 2 is 2x. And then we get x times x is x squared. And so we are left with that expression. So that's just what we said with expanded brackets. If you are not familiar with this kind of thing, I would recommend to go back to the expanding brackets and factorizing session that I did. So that would be ideal to kind of look over that kind of thing so that you can get the idea of it, because those two are going to be very important for these next videos coming up now. So that's you have to get used to that first for single things like this, because we're going to do some crazy stuff now. So we're going to transition ourselves over to quadratics now. So we need to know about binomials. So what is a binomial? Well, a binomial is the difference or addition of two terms in an expression. So in this case, we have two examples here. X minus 1 is a binomial because it's got x and it's got a 1, and then there's a subtraction right in the middle. So that is a binomial. It's got two terms in it, so that's hence bi. And then for the second one, 3x plus 6, that is also a binomial because we have 3x on the left there, and we have 6, and then we have a plus in the middle. So if we go back to these two, we see that this here is a binomial as well, and this is also a binomial. But these two here are just constants, it's just, just outside. So what we need to do now is, what if we multiply binomials with each other now? For two binomials, so here we see we multiplied a binomial by a constant, but now we're going to be multiplying a binomial by another binomial. And we have situations of this. So when you have situations like this, we follow a very similar method to expanding before, but now we have to do a few more steps. So the general procedure for this is, now some places they would teach this, this is called FOIL. I personally was never really taught it as FOIL, I was just taught it as a procedure. There was no real name for it, but you could do whatever you want, honestly, it doesn't matter. As long as you get the answer, that's all that really matters, as long as the method is valid as well. So I'm just going to do the way I was taught it, I guess, or method, I guess, without this FOIL stuff. So the idea is we begin by taking the first term, and we multiply it. We basically treat it as two different. We basically treat it as two of these in a way. So the way So what I mean is to start with x. So x times 5 is 5x, and then x times minus y is minus yx. Okay, that's the first bit. Now we're that done, we take the 1 and we do the same thing. So 1, 5. So 1 times 5 is just 5. Alright, and then 1 times minus y. So then we get minus y. And that is all there is for that. So that is the general method of multiplying two binomials together. We always start with the first term and multiply it out by 5, and then minus y, as we've seen with this. You treat it like this. And then you take the 1, and you multiply it by 5, and then minus y as well after. So you do these two first to get these two terms, and then you do these two after to get these two terms. So we're going to introduce ourselves to a quadratic now. A quadratic is made by doing this kind of operation. So this down here is a quadratic, when you have two x's and then you have numbers elsewhere, basically. So let's quickly expand this out as we've done already. So let's do what we did before. So x times x is x squared, and then x times minus 2 is minus 2x. Alright, we've done the first step there. Now we're going to take the 1 and do the same. So 1 times x is plus x. And then 1 times minus 2 is minus 2. And now we just simply simplify the middle bit there. So we got x squared, oh god. So minus 2 plus x is just minus x plus, oh that's a minus, sorry, minus 2. And that is our answer. That is what we get from simplifying this out, expanding this out, and simplifying after. So this here, this is a quadratic expression. This is a quadratic expression. This is a typical form of a quadratic expression. And now we're going to see what this actually means, or what it actually is. So a quadratic expression is a polynomial with degree 2. Now that's quite a lot of new words there. So let me just break it down a bit. A polynomial is a list of numbers, or a list of expressions. Well, actually no, I should say it's an expression that contains contains a list of variables with increasing numbers, or decreasing numbers of powers, or increasing whatever. So what I mean by that is, example is this here, x squared plus x plus 1. This is called a polynomial, because you got an x squared, then you decrease the power to the next one, so it's just x, and then you decrease it power again, and it's just a number, right? So that's an example of a polynomial. Now, we'll be dealing with polynomials a lot more when we get into cubics, quartics for the A-level stuff, and all that kind of thing. And polynomials are very important. They appear everywhere, and it is good to know what they are, basically. But a polynomial is basically just expression like this. So even the things we've done in the past, with the linear equations that we studied, we've done that with philosophy sessions, solving them. Those are all polynomials as well. So just simply, 3x plus 2 is a polynomial, but that has something called a degree. All of these have degrees. So when you have a squared appearing in the polynomial, this is called a degree 2. If you have, say, back here, we had just this here. There's just an x, and then it's just a power 1, and that's it. This is called a degree 1. So this is a degree 1 polynomial. This is a degree 2 polynomial, because it's a squared, so this is a quadratic. Here, both of these are degree 1 polynomials, because it's just a single x. There's no square, cube, or any of that. In this situation, this is a degree 2 polynomial as well. So this is basically a quadratic. That's what quadratic is defined as. It's a polynomial with degree 2. And that's when you have a squared appearing. So these three are different examples of quadratic expressions. And they can be rearranged in different ways. The standard procedure that I prefer to do is the general form down here, where you have a, b, and c are any numbers, and then you just have x squared plus x plus a number. So when it's nice and organized like that in ascending or descending order. Or you can have it the other direction, where you have it as c plus bx plus ax squared. Both ways are fine. I prefer to have them either the powers in ascending order or descending order like this. But you can also mix them up, such as this down here. It doesn't matter. As long as there's an x, as long as you have a general structure of a polynomial, that's all that really matters. So this is what quadratic is, basically. Now, let's go ahead and expand some quadratics now. So we've already expanded the quadratic down here, but it's good to do a little bit more practice with that. So let's just do it very quickly. So x plus 1 times x plus 6. So let's just do it very fast. So we got to do x squared remember, because we're doing that. Then plus 6x, which is that one there. And then we're going to do the last two, that one and then that one. So we're going to do plus x plus 6. There's a bad 6, but yeah, 6. And then we can simplify it out further, and we're going to get x squared plus, I'm just going to connect that up, 7x plus 6. There you go. That is all you get for that expression. So that is a quadratic simplified out. Again, now let's note that not only x's appear on their own. Now so far we've seen all the x squares appear on their own, you know, like this, but you can also have a number in front of the x squared as well. So we're going to see an example of that right here. So let's do 2x squared times 3x. Let's do 2x times 3x now. So we do 6. And we're going to do the same procedure with expanding out these binomials. So 6x squared right there, plus, and there you go. So we're going to do like that, and then we're going to do like that. So plus 2x. Remember, we're going to do like these two now. So plus 9x. And then, in the end, plus 3. And that is equal to 6x squared plus 11x plus 3. Done. And now for a general case at the bottom, when you have this kind of thing, you would have as ax, I should add acx squared, as we're multiplying ax by cx, so it's acx squared, basically. And then we do the same, we bring it over, we do that one now, so we got plus a dx plus bcx plus, and at the end you get bd. Now this one probably not really needed to know about, but it's interesting to see, you know, how all these numbers would appear. So if you put all these numbers in, set a equal to 2, b equals to 3, c equals 3, and d equals to 1, then this would eventually average out to, well, this would eventually simplify out to just this. So this is just kind of a general form, if you will, but this is not really needed. What's more important is that you understand multiplying out quadratics like this and like this. Now, one last thing, which I'm gonna bring it down to you know, foundation here. This is more of a higher tier topic, but we're gonna bring it down to foundation because this is quite essential as well, and this will help a lot. And again, it's also good practice for expanding quadratics. So this is a process called difference of two squares, and this is a special case of expanding quadratics. So this happens when you have two binomials that are the same, but one is a plus and one is a minus. So all these three you can see down here are the same. So let's say, let's just expand this out as usual. So we got x squared. That's I need to get better with this, but yeah. So we got x squared minus x, so because we did that and then that, and now we're going to do these two plus x, and we're going to multiply at the end of that. Now in this situation, you can see, you know, you got minus x plus x, so that will disappear. You're left with x squared minus 1. Okay, cool. So that seems pretty interesting. Let's see if the other ones follow the same thing. So we're going to do x squared again. We're going to do minus 4x plus, remember we did that one, and then we did that one. Now we're going to do these two. So 4x minus 16. And again, minus 4x plus 4x, that cancels again. So you're just left with x squared minus 16. Okay, that seems rather interesting. So we have kind of a pattern going on here. So let's try the last one. Let's see what we get from this. So we're going to do the same procedure. So let's do this like this, yeah? So 4x squared. I'm going to bring it over that. Minus 6x plus 6x. Oh, that's do better than that. Minus 9. And now what we have here is we have, well, let's just minus 6x plus 6x Let's get rid of that. And in the end, we are left with 4x squared minus 9. And if we look at that, we see that 4x squared minus 9. There you go. So what happens with all of these is that the middle values in the middle here, they all disappear in each case. So you're just left with an x squared and then a constant. And that's what you're left with in each case. So this is a very special case of expanding quadratics, and this is called the difference of two squares. So, and it's called that because it is quite literally two squares being subtracted from each other. You have, in this case, you have x squared minus 4 squared. And you can see it right there, x squared minus 4 squared. And the same down here, you got 4x squared minus 9. So that's basically 2x squared. So 2x times itself, and then 3 squared, 3 times itself. So we have the general form here. If you have ax plus b multiplied by x minus b, then the general form will be a squared x squared minus b squared. So that seems a bit crazy, but let's just put numbers in to quickly test this. So let's say, for example, we have 2x plus 2, and then we have 2x minus 2, and that will give us, if we use the equations here, we will have, let's say a is equal to 4, so 2 squared is 4, and then you just have x squared, and then b is also equal to 2, so we are left with 4, and that is what we get, 4x squared minus 4. Now if you were to go ahead and multiply it out yourself, you could do that if you want. You'll see that you will actually reach this value here. You'll see you reach this expression. So this works. This is this is kind of a shortcut, if you will, for this kind of thing. So let's try one more example. So let's do 3x plus 9. 3x minus 9. And let's do that real quick. So let's say we have, so in the end, we put the a as 3, so 3 squared is 9. And you leave your x squared alone. And then b here is 9, so 9 squared is 81. And again, if you were to calculate this out yourself, go ahead and expand it, you'll see you would get this expression as well. So that is all I had to say on quadratic expressions. It's kind of the introduction to it all, what they're defined as, how you can expand the brackets out. So thank you guys so much for watching. In the next video, we will be taking a look into factorizing quadratics as probably the final tier 1 video for this playlist. So thank you guys so much for watching, and I'll see you guys in the next video.